Hey everybody, here's Mohan from Code For Me. Today we are going to implement AI in a microcontroller that only has 4 megabytes of RAM. I will directly demonstrate with the laser pointer in front of me that is linked to a servo motor and controlled by an ESP32 cam that processes each frame using computer vision algorithm to predict the position of human head and guide the laser pointer accordingly. This means when I try to escape to the right or to the left, it will always follow me. I'm going to delve into the code schematics and really share with you how it is possible that AI can be really implemented in such constrained resources. The first thing we need is a breadboard, and this allows us to connect all components together. A laser pointer, and you need to be careful because lasers are really very powerful. I have used an old laser that I have modified so that I can power it from outside. Next we need a relay, and this is optional. It allows us to control a much higher laser. Let's say we have a laser that needs 100 volt, and with this relay our microcontroller can control these high voltages without having directly to deal with it. And the 50 Hz servo motor that has 3 pins: power, ground and a signal. Our hero today is the ESP32 microcontroller that has a camera integrated, has network capability and SD card support. This low cost, low power consumption, it requires 3.3 volts and can handle up to 5 volts. And I bought it with its development board, and this allows me to easily connect it to the PC using USB, where I can flash it and upload new programs. Connecting is straightforward. The servo motor signal to the GPU 14, the laser through the relay to the GPU 15, and set the microcontroller and power up the board. I have put the code in a GitHub repository, and the link you can find in the description. And briefly, there is mainly 2 functions, one for each core. One captures the picture and the other process them through a prediction algorithm. Honestly, it was really very fascinating to me how machine learning models can fit in such constrained resources. And by the way, the ESP32 AI official library repository contains so many models you can play with, like for example cat face detection or colors detection. And TensorFlow have good documentation on how to transfer almost any model from being large to really small model that can fit in such constrained resources by optimizing and quantizing and sacrificing some of the accuracy. And by the way, the algorithm that I have used today in this project is 83% accurate. So it's accurate, it is worth it, enabling us to do really some cool stuff on a low cost microcontroller. What will you do with this power? It is also responsibility. I hope you enjoy watching, and see you next time.